Hello, welcome back to another episode of Michael Makes Bad Robots. In this episode, balancing robots. So a couple weeks ago I made this balancing robot. Originally I wasn't going to post anything about it because for one, if balancing robots had a flavor, it'd be vanilla. Everyone makes them and they're a pretty easy thing to do. It's basically a pure demonstration of what a PID controller is. So this one uses geared DC motors that look like this. There's like really cheap Amazon ones. However, they actually don't throttle that well, so it barely balances, and because they're basically on or off, so it tends to oscillate a lot. I didn't feel like putting a ton of time into messing with the PID controller and making it just perfect so it balances. So originally I wasn't going to post anything, but as you can see, it does balance, but it is definitely oscillates a lot. So if you've ever taken a controls or a controls theory class, or even just looked into the topic, the first example they usually use is an inverted pendulum. So an inverted pendulum is essentially when you balance a broom on your hand or something like a rod, and it's your hand moving around, keeping it upright. And that's exactly what this does, but using motors and detecting the angle with an IMU. So after the IMU detects the angle, it goes to a microcontroller, which I have an Arduino Nano on here. And what that does is essentially calculates where it is currently versus where it needs to be, and then it adjusts the motor throttle based on that value. To do this, it uses what's called a PID controller, which is probably the most basic form of controller. It stands for proportional integral derivable. There's a million videos on it, and most of them are pretty good, so I'm not going to explain it too in depth here. Go look it up. Whenever I make projects, I usually tend to use close to the same components on all of them. It's just kind of the way it works out. Usually it includes a microcontroller, sometimes an IMU, servo outputs, a voltage regulator of some sort, and then basically just digital pins. So in the past, that's resulted in me having a lot of these type of boards. These are all from past projects. And they all just have a microcontroller, usually an Arduino Nano, because that's good enough for the stuff I do. And it's on this type of cheap green soldered protoboard stuff. And don't get me wrong, this is way better than having all the parts just on a breadboard. However, I've decided that I've had enough of this type of rat's nest in the back. So I made PCBs. So these PCBs allow me to use basically all the same components I would normally fit on a board this size, but it shrinks the form factor, and I no longer have to deal with all of the wiring mess in the back. For whatever reason, I actually really enjoy designing PCBs. I think it's kind of relaxing. Maybe that's weird, I don't know. But I'm not an electrical engineer. It's not what I'm going to school for. So obviously don't look at this as an expertly designed PCB. But I'm hoping it'll be a good platform to improve upon and continue to use in the future. So let's pull them together and then put it on the robot. adapter there. So quickly I'll run through what's actually on here. So there's a voltage in which goes to the Arduino, and then a servo line which comes off of the voltage in, but it goes through this voltage regulator right here, so you can change the amount of voltage you're sending to your 5 servo outputs out here. Then you have a 5-volt line which comes out of the Arduino's 5-volt regulator. The MPU 6050, which is the onboard IMU right here, is powered off of the Arduino's 3.3 volt line because it needs its own, steady voltage. And then there are 2 LEDs, which you can just address however you want. They're just on 2 digital pins. And then you have 3 potentiometers for adjusting different values inside your code, or just another way of changing things with hardware rather than in software. And then here is a series of pins which just connect directly to the Arduino, and that's so you can attach anything else you want to attach that's not already built on here. So you have access to all the digital pins, including the interrupt pins, a couple of the analog pins, and then there's extra I2C lines, just in case you want to add extra I2C sensors. Without any further ado, let's attach this new PCB onto this robot and see if it works. Alright, so the new board is on the robot, and I had to make a couple tweaks to the code because the IMU is actually oriented in a different direction. But other than that, we should be ready to test it out. I'll plug it in. It's where hopefully it doesn't blow up. Now, obviously, the new board did not fix the oscillation issues. It's still running the same controller and everything. But if you guys are actually interested in making a good balancing robot, let me know. Maybe we can revisit this down the road. But for right now, let's go take this outside and see how well it works. Alright guys, thank you so much for watching. I have more projects in the works, so if you want to subscribe so you make sure you see those, that'd be great. Let me know if you guys have any ideas for other projects I can do with these boards. I've got a few ideas, but we'll see. I'm also thinking about making some improved models. Also thinking about designing my own microcontroller with a ARM Cortex chip on it, but we'll see. There's some learning to do before I finish that. So, yeah, thanks for watching. Have a good one.